Hello everyone, Jeremy Morgan here, and I apologize for this stream starting so late. So I had some things come up, got sidetracked, but we are going to do the temperature sensor with the Raspberry Pi, and I'm going to show you guys how to pull temperature and humidity from a Raspberry Pi, store it onto a server. Before I start, now I was going to do a cloud endpoint. So you can go through AWS, you can go to Azure, GCP, and you can do cloud endpoints. And what those involve is like downloading a client onto your Raspberry Pi, doing some configuration, sending up to the cloud. They make neat graphs, everything else. It's really cool. It's awesome stuff. But kind of at the last minute, I decided that we could dig down a little bit deeper with it. So what I want to do is we're going to write all this stuff. We're going to grab the stuff from the sensor directly. We're going to send it to HTTP posts off to a server and write a little Go service that does it. And also, I'm wearing my Go shirt today, so I've decided to do it in Go. If you've read some of my articles on my website over the years, I've done a lot of stuff with Python. And I love Python, and Python and the Raspberry Pi just kind of go together like peanut butter and jelly. However, I decided to see if I could do this with Go. So a few days ago, I kind of cobbled some stuff together and it worked. And so today we're going to do this with Go. We're going to read the sensors with Go. We're going to send it to a Go service on a little FreeBSD server, and we're going to see how it works out. Now, this isn't extremely prepared like many demos and demonstrations that I've done, so you might see some errors here and there, but let's get started. Okay, and I've got my little Pop! OS machine here. And I've got corded headphones today, which is kind of funny. I was going to use my Sony wireless headphones like I usually do, but I had didn't have a lot of meetings at work today. Had a real heads down kind of day, so I basically ran out my wireless headphone battery. So I've got the corded ones, which these are fine. These are 7506s. They're pretty good headphones. All right, and first we're going to connect to the Raspberry Pi. I'm using Ramina for this. And as you can see, I already have a little folder set up here. Let's see, we'll make another one. Oh, okay, so the first thing in the chat is BMP 280 negative. I'll show you what we're running here. I probably should have said that in the beginning here. So I am using the AM2302, and this is a picture of the actual sensor that's hooked up. This is a really super cheap sensor. It works fairly well. It's got a pretty good temperature range and just kind of costs a few bucks. Really easy to interface with. And this is a picture of the Raspberry Pi. It's off in my laundry room. I was thinking about hooking a little webcam to it, but it seemed like too much work since you can't even really see what's going on with it anyway. Basically just lights up and stuff, but I've got it hooked up here. And I have a little picture of the pinout that I'm using. So it's pretty simple. These things just plug right in. And actually for years and years I used the Adafruit libraries, which worked great. But today we're going to do something a little bit different. I'm not even sure if let's try out this. Oh, that's a Python IDE. Never mind. I do believe I have Visual Studio Code on here. Yes, I do. Okay. So right now I'm on my Raspberry Pi, and we're going to write this code right on the Raspberry Pi. And this sensor.go is probably an old one, so we're just going to start all over again anyway. And we'll just call this sensor. Okay, someone's asking, can you show the pinout again? Yes, I can. So I believe it's on pin 7. It's going to be GPIO 21, I think. There it is. And here's the pin out again. So I'm putting it to the 3.3 volt off of pin 1 for the red one. Here, I'll open up both of these just to kind of illustrate it. There we go. So these have a red, black, and yellow wire. And I've got the pin out here. So the yellow wire is going to be your actual signal wire. And I do not have a pull-up resistor on this particular sensor, only because it already has the built-in pull-up resistor in it. But yeah, if you want to take a screenshot of that. Open this up. And I've got some notes over here that I need to find. So I can find the proper library and show you guys. The library that we'll be using is called the Go DHT library. And this is a library for working with DHT sensors in Go. It's extremely easy, as you'll see. This works with the DHTs, the AM2302, which is what we're using. And actually, if you go down here, there's like some of these examples. We will be using the read example. And you can see it's just really pretty straightforward and simple. I mean, we could probably just copy it right off of the site here for the most part. Oh, and you can see I haven't run a ton of Go things off of this Raspberry Pi yet, so let's see. For now, we'll put in this library. And just so everyone knows, I haven't done this for a long time. I've actually got out of the IoT stuff for a few years. I'm a little rusty, but the basics are kind of still there. And here we're just creating a simple Go file. Ooh, that's one of the things I don't like about Visual Studio Code when it does that. It can see that I'm not using the Go library yet, so when you hit save, it just wipes it out of there. Okay, the first thing we need to do is pull a reading from it. So this thing reads in Fahrenheit and Celsius, temperature and humidity. So what I'm going to do is just create a struct, and it's going to have a timestamp, temperature and humidity. And I'm going to store this in a SQLite database. So with SQLite with time, you have to store it as a string. So that's what I'm going to put in the struct here. And we'll call this reading. And just a heads up, I've been doing this for 20 plus years, but when I know people are watching, my typing is terrible. But that's okay. I don't think anybody really cares that much. Temperature. This one I believe should be a float 64. And that's because that's how it comes out of the sensor. It doesn't need to be a float 64, obviously, but... All right, so we got our little struct, and we're going to use this struct all over the place for our readings. So I'm using GPIO 17. So one of the things I like to do is we'll just make a const here. As I said, my typing is terrible. The polished stuff you see on YouTube is because for some reason I could just type fluently or edit it out, but whatever. And Now I'm trying to remember if it was, I believe it's GPIO 17. So since we're using GPIO 17 for the communication, I put that up there. So if you put it on another pin, you can change it to something else. All right. So the first thing you want to do is initialize the host. And that is, yeah, right here, host.init. So we'll put that in. We'll copy it right out of there. Why not? I'll change the error here. Now for this one, I do want to check those errors and print them out because I'm not 100% sure this is going to work the first time. So I definitely want to be very verbose with all those editors here. And then we need to create a new DHT. Which is technically isn't a DHT, but it's compatible. So now here I'm creating a new DHT sensor. There's the GPIO that I put in here for GPIO 17. I'm setting it to Fahrenheit because I'm in the United States, not because I think Fahrenheit is awesome. Actually, I think Celsius is quite a bit better. And then we've got a little error checking to say if your DHT isn't working, go here. And then we'll want to call the DHT read method. So what it does is it will return humidity and temperature. So let's go ahead and say humidity, temperature, creative naming. It also returns an error. So we'll call this read error. Our microphone is right above the keyboard. So. And then we'll call DHT read. And let's see. Copy this code. And one thing I should note, I mentioned earlier about the cloud services. And how I wanted to get down to the nitty-gritty and write some code to actually interface with these. If you're thinking about building production applications for a real thing, like a real production thing, this is not the way to do it. Actually, the IoT Core from Amazon, the Azure IoT Core, all of those are excellent services. They use MQTT, which we're not going to use today. So if you're doing this professionally, for a real project or a real business, this isn't the way to do it. But if you want to truly understand how all this stuff works, then you do it by hand like this. So we've got initialize the host. We've got a new DHT. We're doing the DHT read. So that's going to get us our two values that we need to put in the struct. Oh, but we have the timestamp. So actually, I'll put this at the top. Grab our timestamp. And let's see if I remember how to do this. I've got notes, but it's going to be just time now. But there's a way to format it so that it'll work with our SQLite database. Stamp equals. Time now. And that will be our timestamp that we're going to use. So now we'll create a new reading into our struct. We'll be real creative and just call it new reading. And we're going to put this into our reading struct. Timestamp is going to be, let me look at my notes here really quick. Oh, there it is. So we're going to format the timestamp before we send it over so that it's formatted in a good ISO format that we can use in our database. So that will be timestamp. Format. What's cool about timestamp format is you can drop in custom formats here. So the way the time package works in the standard library is everything is based off January 2nd, 2006 at this certain time. So if you put this in here, you know, timestamp, actually we can close that, open it up a little bit, put in that 2006-01-02, this will actually format the actual timestamp into the ISO format that you need. And if you change these around, you can change your timestamp around. It's pretty cool. It's a good way to do it. Oh, that's right. We need more than just a timestamp, right? We're going to need temperature, which is going to be our creatively named temperature. And then humidity will be humidity. All right, and then that's going to drop that into that struct for us. And we're going to use that struct to just pass this data around all over the place. So, actually, I think I can save it right now. Let's just kind of see what this thing comes up with when I do this, just to kind of do a little sanity check. Do a format, printf, and we'll do timestamp. This is just kind of a check to see if it's working. One thing I've noticed about these sensors, they're super cheap sensors. So you probably wouldn't even use this sensor for like a commercial product. And if you check them too many times, they just don't work. So it's kind of interesting. For any of you that watch my courses and you see this like fast typing, that's not actually the speed that I type most of the time. So we want, what do we want here? We want timestamp. All right, we don't even need to do the timestamp format for that. And then temperature, humidity. Let's run this thing. Make sure I got my FMT library up here. Yep. And I don't appear to have Go installed on here. That doesn't seem right. There it is. Okay. Undefined error. That was one that I forgot to change when I was doing my copy pasting all over the place. That's what happens when you copy and paste, folks. I'm guilty of it every day. Oh, there we go. Awesome. I'm going to put some line breaks in there so that we can actually see it. New lines, whatever you want to call them. And this is just a quick check to verify that the sensor is actually working. Check it out. There's our timestamp in that ISO format. Temperature is 71.6 degrees. Humidity is 46.2. So I currently have this Raspberry Pi sitting in my laundry room, which is probably a little bit warmer than the rest of the house. And we can just sit and hit this thing over and over. But what I'm going to do is I'm going to send it to a server. Oh, look at that. So I just mentioned earlier that if you ping this thing too many times that it chokes. This is exactly one of the things you get is the DHT error, missing some readings. You can't just sit there and slam it. And Tech Gamer is asking, is it air temperature or body temperature measures? This is air temperature. This is basically the just air and humidity. I'll show the sensor again. So this is a super cheap sensor. It's pretty cool. If I can find it now. This guy, it's the AM2302. Super cheap. Just does ambient air. Fairly accurate. One of the things I did years ago was I wired in like 4 of them and then did readings off of all of them, measured the variance between them. Long story short, there is some variance. Not a lot, a degree or two, but if I were running a life support machine or something, I would not run these. So let's hit this again. And it's really not happy with me now. There we go. Okay, cool. So we'll pull this out of here. So now that we know that the temperature is reading, and look at how much code it took to do that. I mean, barely any Go code to read that. And most of that, of course, is because of this library right here. This Go DHT library takes it all out of there. Dumb question. Do you have a video on installing VS Code and Go on a Pi? No, I don't. I just recently wrote an article how to install Go on a Pi, and the reason I wrote that article is because if you just do an apt and you get Go, it'll get you an older version, which isn't a huge deal. Like all this code I'm writing here, I'm not even sure which version of code or Go I'm running here. Let's check. Okay, I'm running the newest version of Go on this. However, I believe if you do like an apt, it will be 1.11. I don't know. But I do have an article about installing the latest version of Go. It's super easy, but it is better to just pull it down and build the binaries if you need the latest and greatest. As far as VS Code goes, I'm using the head melted version, and I don't remember how I installed this. This Pi has been sitting around for a long time, but I'll write an article on that. Because that's also not difficult, but it's not super straightforward either. So I will do a thing on installing VS Code and Go on a Pi. I don't believe it's an apt install for Visual Studio Code. In fact, I'm sure it's not. So the next thing we're going to do here is add in, let's see. I'll just copy and paste from my notes here. And I'm going to make all this code available on GitHub. I'm actually going to write an article that covers everything we do tonight, and then I'll put all this on GitHub so people can grab it. Oh, I love it when it does that. Okay. So we're going to put in some JSON stuff here. I think net HTTP is one of them. And what we're going to do here is just send this in a post to a server that doesn't exist yet. So, find my notes here. And did I delete? I did delete that reading that I created. Cool. That's all right. I can create another one. Oh, now I gotta find my notes for that timestamp though, because we did do a timestamp format. And I'll have to find that in my notes. There it is. There's that super cool little... Oh, that's right, it is right there. Okay, timestamp format this. Then we're going to do temperature, and that's going to be temperature. Humidity is going to be humidity. Cool. Now we have our little struct here that we're going to need. And let's see. We'll create a new request. said, a lot of this stuff I have to check my notes because it's been so long. So we'll create a new const up here. And this is going to be our endpoint, which right now will probably be Golang Workshop. Got to use that domain for something, right? Okay. So we will create something here, request body. We'll just name that rec error, I guess, for now. And we're gonna use JSON. Oh, good, I do have it in there. JSON.marshal. And we're gonna marshal the struct that we just created here. So we're just gonna send that over as a chunk of JSON and a post request to a service that we create. And I'll copy paste. Okay, perfect. And then we need to do the actual post. So that's an HTTP post. Let's see. Do we want to save the response? Probably not. And let's see if I can find my notes on that. We'll call the response resp, and then we'll call the error resp error, I guess. Perfecto. HTTP dot post. Yes. Okay. So this one's going to be. Let's see. I've got something in my notes here about I believe it's going to be the JSON application type. So we'll put in our endpoint. And JSON. And bytes. Create a new buffer for this. And this one will be our request body. Is that what I named it? Yeah, request body. Cool. So this should be enough, even though there's no endpoint to send to yet. And I just noticed that I haven't been changing any of my error messages, so it's completely pointless. So let's do that really quick. Change this to a reader error. Change this to a request error. Change this to a response error. Okay, now I think I have everything here. I'm not sure why declared but not used. So we are using it. Okay, well, I'll just ignore that until we get an error, because I think we're using it. And we've got this request response, and we need to close this response. We'll do that with a defer. Do response. I don't know if I'm going to use this request body or not yet, but I'm going to close it anyway. So now I've got it set up so I can read it if I want to. Run read sensor.go. Oh, someone forgot to put quotes in there. So timestamp format is just a string, and it looks at that string and it looks for that date stuff. There we go. Resp body close. There we go. This of course isn't going to run, but resp error declared, never used. Now it's declared and used. I don't see code barking about anything important. This should send me a 404. If I knew the sensor was going to be this janky, I probably would have used another one. I've got a handful of them, but it's not happy with me right now. Try it one more time. I at least want to get to the 404, right? Okay, there we go. Now the response error should have kicked back a 404, but since that is a domain, it probably just returned 200, so it thinks everything's great. So I think what I'm going to do is create port 5000. We'll call this reading. So this is going to be an actual API endpoint. Now when I run it, we should get a 404. There we go. Okay. For whatever reason, that response error. Oh. Seems to be a theme tonight. That theme is Jeremy is a horrible typist. And horrible at naming variables. I'm going to fix it just so it's correct. Just so it shows me what I think it's supposed to show me. Yeah, sensor still doesn't like me. That's okay. Don't make a liar out of me. Give me a 404. Come on. There we go. Oh, connection refused is even better than a 404 because the connection absolutely should be refused. So this is so Golang Workshop is a site that's just running on a FreeBSD server that we'll be connecting to here in a little bit. And it doesn't have anything open on port 5000, so it doesn't care. Okay, now we're going to create our reader. And instead of creating this, I was thinking about just creating it in BIM on the server, but it's going to be way easier for people to read on here. So I guess I'll just call this reader. Reader.go. Now, with this one, I'll explain a little bit about what I'm going to do. So the thing that we just wrote on the Raspberry Pi grabs the sensor data, drops it into a struct, marshals that into JSON, sends the JSON to an endpoint. So just using that piece of code that we just wrote, you could actually send it to a ton of different endpoints out there. Even the Amazon IoT stuff, even though most of that is MQTT, like I said, I didn't feel like bringing that level of complexity to what we're doing today. But generally right now, MQTT is probably fast becoming the standard for IoT rather than doing it like this. But this is an excellent learning exercise. Learn how we used to have to do it back in the old days. Okay, so let's see. I'll start up my I'm gonna call this one package main 2. For import, I already know what I have to import, but we'll do it piece by piece. Just to start out, we will import net HTTP. Oh, I'm using gin for this. So I probably should state that. So I'll copy that URL. MQTT is a protocol, so it's kind of a messaging protocol for IoT where you send packets into a queue and it handles the messages. It's way better for higher end stuff. Like the stuff that we're doing here with posts and stuff is great. But if you had 10,000 devices out there that were all sending to an endpoint, there's no way this would scale or hold up. With MQTT, you'd have a better chance of scaling and holding up. So it's just basically a protocol, a way of sending messages. I'm sending this in JSON like you do with a lot of API endpoints out there. So if you've never used Gin with Go before, Gin is one of the coolest web frameworks for installing stuff. And you have to install Gin. And I already have it installed on that server that I'm going to because I do some other stuff with it. But it's really cool. If you've never used Gin and you're a Go programmer, it's one of my favorites. It's the fastest, simplest way to make REST API endpoints, I think. So let's see, our struct. We're going to create that again. It's going to look exactly like the other one. Timestamp should be a string. Then it was temperature, which is a float 64. And then our humidity, which is a float 64. I don't know why I typed in. It's a type, it's not a temp. Not sure why that's happening there, but oh, maybe it's because I capitalized it. Okay. Then we need a package main where we could drop in our we could start up Gin in here. So I usually just do router or R for router instead of typing out router like a lot of the tutorials and stuff. Just R is fine. R, and then this is going to be a Gin. We're just going to do a default router for this, and we'll set up our first route. Our very first route will be a get to get the data that we're going to get. And I believe I said this is going to be /reading. I'm not sure if it's reading or readings, but it's fine. We'll put a little anonymous function in here. Gin context. So that's going to basically get our context. So Gin fires up some stateful context. It's really cool stuff. And so I'm going to pull that into my get here and just put stuff here. So what I want to do for this is pull in the last 10 temperature readings. Is probably going to be the best way to do it. So I'll create a function. And let's see. Let's get last 10. 10 should be fine. And I don't think I need any parameters for that. And we're going to send it back a bunch of readings. So query the database for readings. in this function. Now for this one, for the error checking, I'll probably drop in some error checking, I suppose. Let's put in like check. And we'll say error. We'll just make it die on everything, I think. Why not? This is not going to be a production application by any means. This is educational only, so we'll just make it panic, dump the error. That should work. So, let's see. We're going to need a way to save to the database. So I'll drop in a function for that. I'll get real creative with the naming here and just say save to database. Now what we're going to want to save to the database, we're going to say timestamp, which is a string, temperature, which is a float, 64, and humidity, which is a float 64. And these we're going to pull in from a post and then call this function to save it. So, let's go in here. Start putting some comments in here and be a good citizen. And this is all gin stuff here that's, and actually now that I think about it, I believe this is all uppercase. So that would have caused a problem. Post is going to be the, post is a path parameter, which we decided was going to be reading. And then we need to paste something in there. So what I'll do is put in a little function here for that. And call it temp data. And then I can just pass it in here into our post. And I think, and then our run. This is a string. I don't know what my URL will be yet, so you could put URL : 5000. Just going to put in 5000 for now. So with the test data, let's see, temp data. This is going to have to take in the context again. So we're going to do pointer to gin context. Yeah. We're going to pull in so we'll create a struct. And remember, reading is this struct right up here. I called that a func or package. It is not a package. Okay, so we'll pull in the reading. Then we let's see. We'll do this cbind JSON. It's not coming up in that, but we're going to bind the JSON to this reading struct that I just created. So the JSON that gets sent in, provided it's exactly like this struct, we'll be able to bind it here and just pull it right in. And then save to database here, which is our, I call Save to database. Okay. Which obviously doesn't save to a database yet. Now what you can do in here is just return something. So you can say, I mean, it needs to return something. So we'll just do JSON, HTTP, status okay. Let me check my notes, make sure I got that. Yeah. And we'll just create a header. It says status posted. This doesn't mean much, or matter much, I should say. So now we need to do something with the save to the database, right? So I'm going to pull this in. Oops, answer. Oops. Okay. So let's pull in yet another cool GitHub library for SQLite 3, because we are going to need to store this stuff and retrieve it from the database. So I'll put this in here. This is our SQLite 3. What's it doing? Saving reader goes taking a little while there. It's probably linting my code and having a slight heart attack about it. So I do have an init function here in my notes. Rather than making you watch me type it out, so this is an init function that will run when it starts up, and it's going to open a SQLite 3 database connection to readings.db. If readings.db does not exist, it will create it. And then we have a prepare that says, if the table doesn't exist, the table reading, then we'll create it. So we'll create it with the timestamp text, temperature numeric, humidity numeric. And this will create a local readings.db for our application. And because I want it to be outside of scope, it could go anywhere up here, I guess. DB, we'll just create a little SQL.db. That should work. Okay, so now we have a database connection here. It'll create a table if we don't have the table, so let's first pull our last 10. And again, I've got some code saved here somewhere so that you don't have to watch me type it all in. Now get last 10 doesn't take any parameters, but it returns that reading. So let's walk through what this is. Here I create some temporary variables here, timestamp, temperature, and humidity. We run a query that says select timestamp, temperature, humidity from reading with a limit of 10. And I love the fact that SQLite has a limit clause. A lot of database systems don't, and it does make life a little easier. So basically this is just saying select these readings, only 10 of them, and then we'll make a little slice here, drop them in there. I generally I'll just make it 10, even if we don't have 10, it'll be fine. Then we use a scanner here to go through the rows, scan for timestamp, temperature, and humidity, and then we'll append it onto our slice. Last 10 with our reading. And that will append a reading struct with these values in it. And that should give us the last 10. So I haven't run this yet, but I'm fairly confident this should work. So forget, we do need to add something there, don't we? We need to do a last 10. Get last 10. Is that what I named it, or did I? Oh, I spelled it out. So here we'll grab the last 10 and then we'll spit it out as JSON from our context. So 200. And then, let's see, gin.h. We'll just call it message. So what we can do with this, and I'm actually going to do a series of these streams building on this. And in one of the future streams, we're going to take this API and I'll attach React to it or Vue or something. And we'll actually pull out that data. Maybe we'll do some D3 cool graphing stuff. But for now, I'm just going to stash it in the database and pull it back up. I think this is all I need for this part of it. That's why that one. So, some more comments in here. So now this should read the last 10. I mean, I might be able to run it at this point. I'm doing long iterations here, which is something that I generally don't like to do in a professional setting. I don't like to do long iterations. I like to just insert something, try it, insert it, try it. Or if you're doing test driven or whatever, but should probably make sure this works. So this is reader. We go run. Yes, that's right. It needs a file extension. All right, so let's see what it doesn't like. It doesn't like my lack of commas. Put it up here. It probably doesn't like this function that does nothing. Let's see what it's. I typed out the word function. So here's one of the problems of knowing a ton of programming languages. It's so easy to get this stuff mixed up all the freaking time. So let's see. So I probably don't have Gin installed on this machine. That's okay. Figure this out as we go. Doesn't have a run method. There we go. Doesn't like reading struct. All right. So did I have anything in my notes about that? I don't think I did. Reading. Oh. Duh. Caught my own error there. Okay. How did we end up going back to that? Unknown timestamp instruct literal of type reading. Yes, so my capitalization is a little off, isn't it? Where did I mistype timestamp? Well, that one should be right. I'm on the wrong application again. There it is. Here's the one where I made the typo. Okay. So where did I forget to capitalize? In the struct itself. Cool. Now it should run. There we go. Now we're listening and serving on port 5000. Obviously, we don't have any temperature readings in there yet, but let's just see what it looks like. Boom. We have no readings, but this is what it will look like when it's done, and we will have readings. I'm actually going to push it onto a server, but very cool. So we're getting somewhere. Now we need to actually save to the database. So we've got our last 10. Put a few more comments in here. Query the database. Tables. Okay. So for our function save to database, let's see what notes I have about that. I do have some notes. Awesome. So to save you guys watching my fumbly typing, I'll put this. So here we use prepared statements, which is always cool. I typed in function again. This is fine. Okay, so we're going to insert into reading timestamp, temperature, humidities, values, question mark, question mark, question mark. So you can probably guess. Actually, we could put some error checking. Around that. And then it is statement exec. And for this, so we prepare the statement, which is insert into reading, whatever. It creates an SQL statement. Every good database does some kind of prepared statements rather than just dropping in wild strings. But we are still kind of dropping in wild strings a little bit. This is not a super secure application. But in here, we just want to do, you know, timestamp, the temperature, and the humidity. If you did want to do some security stuff, this would be the place to do it right before you're dropping it in. You could do some scans to make sure it is truly a timestamp, make sure there's no SQL statements in there, make sure that the types are correct. There's all kinds of stuff you could do that would make that better. I thought I named my little error checker check, but quite possible that I did not. Oh, I capitalized it. The joys of live coding. Okay. So this should save everything. So let's go back through our little service here. So the very first thing we do is we create a struct. That struct is what we're sending off from the Raspberry Pi into this server. We've got a database here. We open up the connection. We're going to store it in readings.db. If it doesn't exist, that will be created. And same thing with the table. If the reading table in that readings database doesn't exist, it will create it. It's a super simple table. We're not indexing it. We're not doing anything like that. This is just educational purposes. Then we execute that statement. No error checking on there, though. I probably should add some. So in our main, that's with the init function. In our main function here, we start up a gin router. If it's get reading, then we're going to grab some stuff out of the context here. Don't even know that we need to do that. And we're going to get the last 10 readings from the database. So get last 10 just shoves that back in there, and then we'll put it back in something called message. So for the post, which is where we're actually sending the data from the Raspberry Pi, that post is going to also call reading. It's going to send in this data, which we're just taking this and creating a struct, binding the JSON to it from the context, and then we're just putting these arbitrary messages. Doesn't matter. This is the place where you would put errors. This is where you would put anything that you want to send back to the Raspberry Pi. If you wanted to put checking on the Raspberry Pi side, you could put something in here to do some checking. Our save to database here, we just prepare a string, makes our SQL statement. We execute it with these inputs. We're good. There's our last 10 that we've already gone through in our check. So I think we're ready to actually try this out in real life. Check my notes because I feel like I'm missing something out of this, but see, I've got database SQL, got Gin, got the SQLite library. Everything seems to be pretty good here. So let's see here. Just for the heck of it, we'll run it again, see if it does anything crazy. Doesn't seem to be. Seems to be running on port 5000. So, I'm going to create another terminal window here. I'm going to SSH into my little FreeBSD server. And I'm using Amazon AWS Lightsail. It is awesome. So if you want a server, you know, for years and years, we use these VPS, right? These virtual servers. And Lightsail has virtual servers with really good specs for really low prices. This is one of my just playing around, goofing around servers. I think it costs me $10 a month, but it's great. And don't worry, we'll push this stuff to the cloud. In future streams, I'll push some stuff to the cloud. But for now, we're going to roll it all by hand. So let's see if this works. There we go. All right. Where am I? I'm an EC2 user. I'll just create something called services. Okay. All right. Copy this, and what I'm going to do is just use SCP, and we're going to SCP our files over here, which should be just one file. Oh, we've got a readings DB, so yeah, we could send that over. EC2 user at debuggingworkshop.com. And this is going to be home, EC2 user services. You can tell I've been in Windows lately using PSCP. So SCP comes with Linux, Unix. PSCP is a PuTTY utility that you use in Windows, which I may not be using this correctly. Got my identity file. Oh, I know what it is. I'm not telling it what to copy, which is everything. Okay, so now I've sent reader.go and readings.db to my FreeBSD server over here. Cool. Ready to go. Let's just try running the reader and see what it does. All right, so we're running in debug mode. Not a big deal. Let's see what it brings up. GoLangWorkshop.com. And this is going to be reading. Oh, we are not using HTTPS for this. So there's our service. Yay, it worked. So now let's copy this and let's set up my little Raspberry Pi in my laundry room to start sending some data over here. There it is. So, oh yeah, there we go. I think I got that right. GoLang Workshop 5000 reading. Yep. Cool. So now I'll run it. So there's two different ways that you can do this, what I'm doing right now. First thing I'm going to do is just run it by hand. Let's see if it comes up in our list. Nope. So we may have an issue. I'll run it a few more times. I probably should put some, probably just echo out some things in here so I can kind of see what's going on. We're kind of running blind right now. It could be that the database isn't writable, but it should be. So let's echo some stuff out and see why it's not doing this. First thing would probably be our reading. We'll make this look fancy. So we'll just do temperature and humidity for now. Undefined. So that's probably why it's not storing anything, is our sensor is being goofy again. Or I have a casing issue. One or the other. I have a feeling that the sensor isn't grabbing anything, which is why I'm trying to grab this part. And I use print line instead of print F. Now let's try this. Oh, that was a good reading, so this should store in the database. Now we got an error. But I know I got one good reading out of that, so one thing I'm going to try is deleting that database. I have no idea how many empty ones are in there, so I'll jump back onto my FreeBSD server here, which I believe is this one. Did I close that terminal window? I should not have. Bye-bye readings.db. Okay. So now we should be working with a new database. Got a good reading. And we still don't have anything from here. So might have to do a little debugging on the FreeBSD side. Since we know we're getting good readings out of this, we're not getting any request or response errors from it. So I think the place to look is probably on the FreeBSD side. So what I'll do is just start putting a bunch of printout in here. Go into temp data first. So junior developers, if you like to put in "we got here" all over your code, you're not alone. And some people do it for years and years and years. Copy these back over again. I'm kind of wondering where my terminals went. There's one. Just remove that just to be sure. All right. Let's see if it says anything when I hit it. Which actually, Jin will put out something when I hit it also, but I just want to make sure it's being called. There we go. We've got 2 hits to reading. However, I'm not seeing my print output. Context pointer. Put this in here. If the request method is post, which it should be. See, in here you can take that context and say if the request method is a post, then we'll do these things. And so perhaps that's the part that I'm missing here. I'm almost sure of it. So I'll save this. We're going to copy it back over again. Then we're going to restart it again. So I don't necessarily, well, we'll keep it open just for the heck of it. Go back to our little pie. Come on, my friend. Let's do this. There we go. We've got a good reading. It's a good sign. Still nothing on here. So I'll just go through all my notes here, make sure I'm doing everything I think I should be doing. Start from the top. The init function opens up database. Hello, put 367. Thank you for joining. Actually, this can just be a print run. Why not? So save this. Push this bad boy back over again. Very interesting that the print output isn't coming out. It's been a long time since I've had to do this with Gen, but I thought it would output something, but maybe not. So let's check our pie again. Be sending to Golang Workshop 5000. Does body close? I will figure this out. Now, one thing I could do is take a look at the database. So I'll run this a bunch of times and see if the database is actually collecting and it's a display issue or if it's just not collecting into the database. So for that, I'll just do SCP in reverse. Hi, Random Adventures. The screen image is super small when I'm on the Pi. So this is the Raspberry Pi window. When I go back to the other service part, it is not quite as small. Because in this window, I'm actually RDP'd into my Raspberry Pi. All right, now I've grabbed the database back from the server. We're going to see what's in it. Probably nothing. Exactly nothing. So let's put some stuff in it, send it back over via SCP, and see if it displays anything. Since this is just test, doesn't matter. 40 point. You know, we'll just put in random stuff in here. Attach. It's not letting me do that, huh? Write changes, close out of that, open it back up, see if it really did right. Possibly I would get an error on the timestamp. We'll find out. I think it should be fine because it's just free text. It's not a true timestamp on a database. And that's just kind of a limitation. So we do have one record in here. That's good enough. I'm going to send it back over. And we'll see if those show up. There it is. So that's a little test that I SCP'd the database down to my desktop, added that in there, and then SCP'd it back. So the display part of it is working fine. It is a storage issue. And I suspect it's this guy. So let's get reading. We know that the get's working just fine. It seems to be this post part. Silent Coder said, were you just making sure the UI could read the DB? Yes, I was making sure the display portion was working. So just basically wanted to ensure that the service is grabbing the data out of the database and displaying it on the screen. Because if that display was broken, it would display a bunch of zeros also. And maybe we're storing all these temperatures, but it's not displaying. So I just wanted to make sure. And we are displaying. So the problem is on the storage side of the database. And now that I look at it, I can see exactly what it is. I never did complete the save to database functionality. I feel like a moron right now. But that's okay. Like, everyone makes mistakes. This is what I tell new developers. So I've been a developer for years and years. And I've been a lead developer for probably more years than I was a regular developer. And so I would work with junior developers after a while. And I really tried hard to not make them feel silly when they made mistakes, which is what people did to me for the most part. A lot of people were like, I can't believe you did that. That's stupid. Well, when I became a senior developer, then I was like, don't feel stupid when you do something stupid, because if you hang around long enough, you'll see me do something stupid, and I'm going to own it. Or maybe I'm just terrible at this. I don't know. Okay, so we determined that it wasn't saving to the database, and that was because I did not make a call to my function here to save it to the database. Now we are doing that, and basically we're binding the JSON. This may not work either, by the way. This is kind of blind also, but we're binding it to the JSON that's coming in from the context, taking those bindings, dropping it into my save to database function, which should build a SQL statement and should save to the database. We hope. So let's SCP it over there again. And then we're going to go back to the little screen, the little pie here. Please give me some good reading. Got one good one. Another good one. All right, the suspense is killing me. I got to see if it's actually storing it now. It is not. So, and I know exactly why. I'm sure many of you watching do too. Because I did not restart it. Okay, now we got the new server. Hopefully running here. Go back to our little pie. There's a good reading. Another good reading. And there's our readings with our timestamps and everything. Let's run 10 of them so we can see what it'll look like. Or we'll just delete the database and start over. And then we'll do 10 of them. So go here. Remove our readings. DB. And go run reader.go. So if you were going to build an application with this, you're noticing that I'm running go run reader.go. That's just so I can start and stop, maybe do some edits, weird stuff like that. But you would want to just do a go build, probably pull this from source. So like put this into a GitLab or GitHub or something, pull the source, build it, and then run it as a daemon in the background. And preferably, I would say if I were using this for something real, let's say, and I'll talk while I send readings to it. If I were doing this for something real, I would do the reverse proxy with Nginx and have a reverse proxy that goes into that service at 5,000, does a little protection. I would do it a lot more input sanitizing. I would put some authentication in here. I mean, it could be anything. It could be a token. You could do it by IP. You could say, if it's coming from this IP address, do this. If not, because as of right now, any of you guys who are watching this, you can actually load up Postman and start sending data into my database. Really mess with me. But it's not secure whatsoever. So if I were going to make a real application out of this, those are some of the things I would do: is lock it down by IP, do some input sanitizing. SQL injection errors are always fun. Thank you, Put367. I absolutely love teaching. And I don't claim to be a Donald Knuth or a genius or anything like that, but I do claim to be very enthusiastic about code and building things. It's a lot of fun. Teaching is even more fun than building it sometimes. Oh, there's a new error. So we didn't get this error yet. We got missing some readings. But this one says bad data humidity. Not even sure I've ever seen that error message from there before. So let's go check out and see, since we're dropping stuff in here. Yeah, we've got quite a few more readings there. 71.6. Obviously, there's not a lot of variation because this is an actual temperature sensor in my laundry room. As I said, it's 71 degrees in there. So that's, I guess, another thing I would do if I were making a product out of this is, since those sensors are so cheap, I would build an array of them and then average across them. So what you could do is you could take 4 of those sensors, take 4 readings, do an average across them, and then check the variation to make sure that there isn't one sensor that's way off. So like right now it's 71 degrees. You could take a sample of all 4 of those sensors and say, you know, plus or minus 1 degree is where they should all be. And you could just do an average across them, and that would probably get you the most accurate. Like right now, we're not seeing very much variation at all. So as you take these, if you have 4 sensors, 5 sensors, whatever, you can basically check them. And if you have one sensor that says 60 degrees and all the other ones say 71, then you can say, okay, that's a bad sensor. So here's one problem that we're going to have with the current design is I think it's going to be limited to, yeah, there's those ones now we're just tacking onto the bottom of this. Let's change it up just a little bit. We'll do 20 of them. Actually, we don't want to remove it. I'm going to pull it back in and take another look at it really quick, like we did before. So one of the things... Okay, so now I've SCP'd it down back from the FreeBSD server back onto my Pop! OS desktop. Let's check that thing out and see what it looks like. So the humidity, I'm in Portland, Oregon, so the humidity here is pretty much always around this point, and temperature hasn't changed much. So one thing, let's see, I've got 14 of these. One thing I'm trying to figure out is where these 0 ones are coming from. I've got a bunch of these here. I've still got ones with 0s in it. So I'm just going to delete it and restart it, see what it does. And I'm just about to wrap this up and go spend some time with my family, but I at least wanted to make it work before I did that. Okay, so readings DB is blank. Boom, now they're still showing. Okay. It's probably because it's loaded into memory. There we go. Now they're all blanked out. It's all 0s. So go back to my friendly little pie, wherever I put it here. There's some checking I could put in here for sure that makes sure that it only sends what I want it to send. I'm not even sure if it's sending anything when the sensor has an error, which this sensor I'm going to throw in the garbage because I can already tell it's not up to par. It was just one that I found. And there's my little sensor reading here. So before I close this up, I'll reiterate again that you can do this stuff on the cloud, right? And since I started in IoT probably 4 or 5 years ago, and then I didn't do any IoT for 3 or 4 years, I've just recently started to get back into it. When I started out, this was very common to do everything by hand like this. Now IoT has become this big, huge thing, and there's 3 big cloud services. There's IoT Core from AWS. There's Azure IoT, there's GCP IoT, so all 3 of those. And then there's a huge huge amount of like cloud-based IoT hosting services out there. There's a bunch of really cool ones that I've played around with. So if you're going to build an actual product, and you want to actually do something with these temperature and humidity values, this probably isn't the way to do it. But I suggest you go through and do something like this. Like I built this in Go. You can build it in Python, Rust, C++, whatever you want. And I highly recommend you go through the steps of reading the sensor, preparing the data for travel, pulling it into a service, storing it into a database, then retrieving it from that database. And the reason why I think it's important is you get down to the nitty gritty, you've got full control over everything that you're doing with it. And then when you move into a service, say if you go to AWS Core, you know, you're going to download Node and a client onto your Raspberry Pi. You're going to do some configurations and it's going to build all this magic, you know, and all of a sudden it's going to be iterating, sending data. You're going to have all these cool visualization graphs, but you're not really going to understand how the things are put together and how they're working. So I would suggest doing something like this where you get in manual, really get in and write some code. As you've seen this whole time, we haven't used any web interfaces or anything like that. So I would suggest, you know, getting in there and really digging in, writing the code. When you're ready to build something real, then you go to AWS IoT or even like Heroku or something. You know, there's several different options you can use, but I would suggest first really just truly understanding how these things work. And then when you get into things like MQTT and things like that, it'll make so much more sense. And you'll be able to build some really cool stuff. So those cloud services do a lot for you as far as, you know, you don't have to hand wire up all these databases and things like this. It's all pretty much turnkey, batteries included. But I do suggest really digging in and getting to know it at this level. So just as a recap, if you showed up late, we went in to the Raspberry Pi. I used this library here. And on YouTube, I will post links to all of this stuff. And I will put this all on my GitHub. If you follow me on Twitter or YouTube or wherever, I'll put this all on GitHub. But we started out with this readsensor.go, and we used Go to read a sensor with the Raspberry Pi and grab this humidity and temperature information. Then we bundled it up and marshaled it in some JSON and then sent the JSON into a post into a server. And that server or service is here. And we created this reader.go. I guess you could call this a microservice, but don't get me started about microservices. But we created this reader.go here. And what this did was read it in, takes that post, stuffs it into a database. We're using SQLite for the database. That's a local database. Really small, really easy. If you were taking temperature from 100 different sensors for 10 years, then SQLite would not be the choice that I would make. However, for something like this, it's perfect. It's small, it's fast, it's easy. So built this service where you can post the JSON to it, stores it in database, reads, takes it out of the database. Then we just bundled this up. I SCP'd it over to a FreeBSD server that I play around with, and we just run it as a service. So to get this closer to something that is real in production and usable, I would go onto the Raspberry Pi, build that into a service. You could run it with cron, you know, and have cron run it once an hour, once a minute, whatever. Or you could just put a loop inside there and have a loop that samples. I would not suggest sampling the sensor every second because more than half of them will be those bad readings that you saw, but you could sample it once a minute and just have it run that as a background service. Then take this reader.go, run this as a background service on the FreeBSD server and put Nginx in front of it. It's super easy to do. It's like 10 lines of code. You can even attach a certificate on it and all that kind of stuff. And then I would work a little bit on the security, of course, creating some keys, whatever it takes for security. You could use key authentication. You could use IP authentication, all of the above, tokens, auth tokens, whatever. All of that stuff can be put in here, and you could build a really cool, awesome IoT service. So I want to thank everybody for watching and chatting with me and hanging out while I cobbled this thing together and made some silly mistakes, but we got it to work. We've got a working service and database. I'll put this on GitHub so that other people can use it, play around with it, try it. Some of this stuff obviously was things that I did not write, like gin and the SQLite library, things like that, but I'll make it all available. I'm going to do an article that covers all of this stuff and put that on jeremymorgan.com. Hopefully in the next couple of days, we'll see. And yeah, we'll have all this kind of step-by-step available, and then I'm going to build off of it. So in future streams, follow me on Twitch or YouTube. In future streams, I'm going to build off of this. I'm going to put like a web interface on it with some visualizations and graphs, and we'll probably go in and put in some of that security stuff that I talked about, and we'll make this cool, and maybe after a few weeks we'll have a cool project. Anyway, so thank you for tuning in. Follow me if you want to see more. We're going to keep building on this. Who knows where this is going to go, but thank you very much.